No, I don't know. Well, hello. What's up? So today what we're gonna do is just a quick algorithm. Sometimes I find that people a common question that's asked through the interview process is having to do with array manipulation. Reversing arrays is a big thing. I actually have a video that shows like 5 different ways to reverse arrays and reverse strings, turn them into arrays. So that's a very kind of common thing. But what we're going to do today is write an impure function that reverses an array in place. So a pure function is something that doesn't mutate the array. So you'll bring in a bit of data, and then usually you'll make some kind of clone of data and then manipulate that. In this one, we're not going to do that. So this isn't like great best practices, but it's something that is a little bit tricky if you don't actually know how to do it. There's a couple moving pieces, and uh, there's a big piece of it that is useful in many other different kinds of algorithms. So let's talk about this for a second. So for this one, let's say that we wanted to reverse an array in place. So we're fed an array or a string that we can turn into an array, but let's just keep it as an array for right now. Let's say that we're fed just 1, 2, and 3. And we want to reverse those to obviously be 3, 2, and 1, right? But we want to do that on the array that's passed in, and we don't want to like push into another array is what I'm saying. So there's this idea, and I remember when I first started programming years ago, I was trying to figure out how to do this on my own, but I didn't really understand. I didn't know what I was doing. So there's a paradigm that you can come up with about flipping elements within an array, and that's temp equals first, and this is in a broad sense. Temp equals first, first equals last, can't spell, and then last equals temp. So that's if you look at it, let's say that we have this 1 right here, we'll equal that to a temporary variable that is stored over here, for example. Then we'll equal the first element to the last element, so we'll equal this to this, so now this will be 3. And then we'll equal the last element to the temporary, which was actually equal to the first, so then that'll be that. And for this small array, that would finish the algorithm, but we want to make it to where it doesn't matter the size of the array that's passed in. Okay, so let's get after this. So, one other thing. Well, I'll explain it as I go. So let's just say we have const reverse in place, right? I'm going to make spelling errors. I'm going to make spelling errors. That, it's passed in an array. And then when we have that array in there, we want to go ahead and declare that temporary variable that I was talking about earlier. So we declare temp, and then we loop through the array. And we got to use an old school for loop for this because we're only going through half of the array, and that's the part that I want to explain. So I equals 0, I less than r dot length divided by 2, and then I plus plus. So what we're doing here is we're looping through half of the array, the length divided by 2. Quick thing about that, I used to get confused as to whether I would have to have less than or equal to half of the array. But really, you only have to have it. Less than half of the array. The reason is if you have, let's just say, 5 elements in the array, and you go 5 divided by 2, that's going to give you 2.5. If you have 2.5 as your midpoint, then your loop will actually run to the third element. Because if you think about it, less than or equal to 2.5, and they only stop at whole numbers, less than or equal to 2.5, 2 will still be there, but that's actually where you want to stop. So it'll actually go to 3. So you always want to remember, it's just a little gotcha bullshit, less than r dot length. All right, cool, divided by 2. So less than r dot length divided by 2, I plus plus. So now let's do our array flipping that we talked about earlier. So temp equals r at I. So that'll be your first element in your first loop, the first iteration of the loop. And then your first element, r at I, is going to equal r at r dot length divided by 2, or not divided by 2, minus 1 minus I. I mean, come on, man, it ain't that hard. So r at r dot length minus 1 will give you the last element, but then you want to go minus I because each time you want to move the last element down to the left of the array. So the minus I will be 0 at first, so it'll be last element minus 0. then it'll be last element minus 1, last element minus whatever I is at. So that's how we do that. So then r at r.length minus 1 minus I, that's going to equal the temp that we stored earlier, right? So then all we have to do is return the r. Okay, so let's see that this works real quick, and then we'll talk about some stuff. Reverse in place, and then we'll feed it an r, and then we'll make an r up here, and let's just do that 1, 2, 3, 4, 5, 6, 7, 8, 9. That's nice and easy. So let's console log this and see if it works. No legit scratch. Boom. So 987654321. Okay, so if you think about it, what this is doing is it's taking in an array. It's actually changing that array. So if we console log, if you look right here, if we console log r right here, actually let's declare it first. So right here, if we declare that array and then we console log it right here, and then we run this, and then we console log array again, what we get is, what you'll see is that this is the original array, and then this is when we run the function, and then this is the array in the global execution context on the global scope. This is what it is. So we've actually mutated the array. Now that's 99% of the time you don't want to do that, but in this example we were wanting to reverse the same array in place, and I wanted to give this bit of logic. So let's say, for example, that you, and we'll just do this as kind of a one-off real quick. Let's say, for example, that you didn't want to do that. That you didn't want to mutate the array. Well, there are a couple of ways that you can, I mean, obviously there's a million ways you can do it, but let's go through one very easy way to where, just as an example, to where you wouldn't mutate the array. So let's just go cons reverse, and we'll just name it cons reverse, and then we'll pass in an array, and then that'll be a whole thing. And then let's let result. So what we're doing right here is we're setting up another array that we're going to actually return, and then we'll just use the for let of syntax. So lm of r. So if you're looping through arrays, it's of. If you're looping through objects, it's in. And then we'll just go result dot unshift. What unshift does is just shove an element into the beginning of whatever array that we want. We're shoving it into result. And then, I mean, basically after that, this is a lot less code. We can just return result. Now, if we run the same thing to where we make an array right here, and let's just keep it the same array, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we console log array right here, and then we run the function, we'll go console log reverse right here with the array passed in, and then we'll console log array again. So if we run all this, what you'll see is that in this example we get what we want as the output, so that's result, and then on our global scope this is our array, and then this is our array again, so it wasn't mutated, and that's what you normally want to do. That's called pure functions. So if you look up pure functions, it'll talk about, it's a programming paradigm to where you take in data, you don't mutate that data, and you output something from that data, but that it's something that isn't the exact same piece of data. It's not mutated. Mutating means that you affect the data that's brought in. All right, so that's basically that on this reversing in place and small talking on like pure functions and things like that. So I hope it helped. All right, take it sleazy.